this is Tanner Tech, and today we're going to be doing something interesting. So, as you can see in the title, it is titled, My Lab is Your Lab. And what this means is, in this video, I'm going to be allowing you to use my electronics laboratory. And by this, I mean just go in the comments. Hello, how are you doing? So, in this video, what I'm going to do is I'm going to look at the comments, and people can tell me what they want me to do with my electronics lab. And by this, I mean that if you want anything done, if you want me to take some components and blow them up, or if you want me to build a certain thing, then by all means, go ahead. So, thank you, cool boy dude. Well, anyway, anything you want me to do, any parts you want me to build, any things you want me to do, I'll build them. But for now, because that would be boring until someone tells me what to do, I'm going to be working on building an inverter and telling you everything that happens with this inverter while it's being built. So, if you have any ideas for what you want me to build, anything you want, any ideas that can be built relatively quickly, share them in the comments. But for now, I'm going to do a step-by-step on building an inverter. So, let's get started.
Yeah, I've got to run to Walmart.
Okay, so building an inverter is relatively cool. So what we're going to do is we're going to be using this microwave oven transformer, which is quite heavy, and it is wound for... This microwave transformer is wound, so that way we have two wires coming out, and they are center tapped in the middle if we connect these two together. So we have 12 between here and here, 12 between here and here. Now, what we're going to do is we're going to be following this schematic to make this inverter work. And just remember that if you're just joining this video and you have an idea for what you want me to build, I'll take a break on this and build whatever you want. That's why this video is called My Lab is Your Lab. Now, how this inverter circuit works is we have two capacitors right here, and we have two MOSFETs and two transistors, and we have our transformer right here. Now, this oscillator circuit, pretty much what it does is it uses these two transistors in conjunction with these two capacitors and these four resistors to actually make a circuit that is able to drive these two MOSFETs simultaneously at 60 Hertz. Whoa, that's pretty cool to whoever just commented they're watching in India. I'm broadcasting from California, so it's pretty cool. Now, anyway, what happens is the electricity flows from 12 volts, and it flows through the center tap of this transformer into the drains of both MOSFETs. Now, nothing happens yet until the electricity flows through all these resistors to charge these capacitors and at the gates. Now, what's going to happen? You know what? I'll wait to explain that. Let's start building. So, what we're going to do is we're going to follow this circuit to build everything how it should be built. So we're going to need two MOSFETs. Now we're also going to need some other supplies. And that is what this part is for up here. Just a second. Okay. Cool. Nice job watching in Texas. Now what I'm going to do is I'm going to grab some components. Now it says to use 2N222 transistors, but I'm actually just going to be using 2N3904. So I'll walk over here, find a 2N3904. I've got a bunch of them in this bag. I'll just take two of them for the project. Now what we're also going to need is some resistors. Now if we look at the schematic, you can see that we need to have a 680 ohm resistor. So let's find one. Come up here. 500 to 1K. Now we look inside here. We kind of look through our resistors. you can see that I can find a 680 ohm resistor inside here to build the thing. So I'll take out 2 of those, set them aside, put some of the other resistors back in place, and we'll start finding the last few components we need. Now, in the schematic, okay, I got a comment that just asked, how do I organize my bench? And that's a very good question. Thank you, cool boy dude from Texas. Now, if we look right here, we can see my whole desk, and I'll scoot my camera back more. Okay, so someone asked, how do I organize my bench? And that's a very interesting question. So over here, I have kind of my power supplies. So I have my Variac transformer right here. Right now it's charging my iPod. Then I have my soldering iron and light and DC power supply right here. This DC power supply can supply variable voltage and current. Then over here I kind of have my radio station, where I have just this radio receiver, a 10 meter transceiver, 70 centimeter and 2 meter transmitter and receiver, and then a power amplifier right here for everything else. I also have a 12 volt power supply right here that can supply up to 55 amps. Then I have my oscilloscope, and then all of my bins that have my different components. Let's take a closer look at those. So if we take a look right here, we can see all of my components. And someone asked me to explain them. Now over here I have all my capacitors, and they're kind of in a lineup here. These capacitors are film capacitors, and then all my ceramic capacitors. Now I didn't do too good of a job organizing these. So down here we have all the electrolytic capacitors, ranging from 1 to 1,000 microfarads. Also I have some alligator clips right here. Then if we look over here, I have all my resistors organized, going from 1 ohm to infinity ohms right here. Then I have my potentiometers, inductors, push buttons, my screws and other fasteners, some buzzers and voltage regulators. Well, you know what? I just have all my components organized in all these drawers. And it makes it very easy to find which component I actually need to use. Because I have everything I need, from semiconductors to resistors to inductors to capacitors to switches and relays to everything else I will possibly need when working on an electronics project. Okay, so now back to the original thing we were doing, which was making this schematic. Now if we take a look right here, we're also going to need these 16.5K resistors. So we'll take a look at those to find some. And also keep in mind that while you're watching, this video is called Your Bench, My Lab is Your Lab. So by this I mean, if you have any suggestions of what you want me to do, you can. Now someone suggested that I show them how my bench is organized, so I went ahead and did that. Now if any of you want to know anything about electronics, you can suggest in the comments for me to do anything from testing components in the oscilloscope to just connecting stuff together to make it work. Okay, so I don't have any 16 ohm resistors, sadly. 16K resistors, and I can't find any inside here. So we're just going to have to make do with 15K resistors. If I can find some in here, I might. No. So we'll get two 15K resistors, because those will work just as well. Now keep in mind this is my first live stream, and so I'm doing the best that I can here. I don't really know exactly how to make a live stream. I'm used to making normal videos like this. But I'm giving it a go. So let's see what we want to do next here. So we have mostly all of our components. Wait, I forgot to get an electrolytic capacitor. So let's find one of those. Take a look at my electrolytic capacitor drawer. Find 1 microfarad. And we can take a look at my different capacitors and find one that is the right rating. 0.1 microfarads are not going to work. I can grab these. 47 microfarads are not going to work. Can't even read that one. Oh, 22, not going to work. Sometimes it's kind of hard to find the right components. Why is there 1,000 microfarad in there? Okay, this is being a little bit difficult to find the right 1 microfarad capacitor. Let's keep looking. .1, not going to work. .1, not going to work. 2, not going to work. Not going to work. Not going to work. I need to find one. Okay, so this is the perfect example of me not being able to find the components I need. Now, usually what I do here is I go into my components, and I go into all my old circuit boards, and I find all the components I need, and I desolder them. Now, I haven't done that for like a few months, and so I'm running low on components. So as you can see, I don't have any 1 microfarad capacitors. So we're going to have to diverge a little bit from the purpose. We're going to have to go find some capacitors and desolder them. Kind of restock my supplies. Oh. Okay, someone asked if I solder in my room, and yes, I do. So, yeah, that's my soldering iron. It's in my room. And if I need to solder, I have a soldering fan. So we're going to come over here to come and find some components. So if you look inside my closet, which is kind of messy, I have a whole pile of circuit boards. We're going to have to find a 1 microfarad capacitor for our inverter circuit. So let's dig through here a little bit until we find a suitable board. This board looks like it may have some... Nope, no 1 microfarads. This board looks like it's going to be promising. So I'll take a look here. Oops. I'll be right back with some cutters. Okay, I'm going to cut the cord off this one. It's too buried. So this circuit board has lots of small value capacitors, and one of them ought to be 1 microfarad for use in our inverter project. First, let me clean up a little bit here. It's always a mess when I have to find a circuit board. But these are all the circuit boards I've collected over the years. They all have different components on them that are useful. So let's head back over here to the desk and find a 1 microfarad capacitor. Okay. So, let's take a look at this circuit board. First, I'll fire up my soldering iron so I can desolder stuff. And we're going to take a look at some capacitors. This requires a little bit of skill to look at these things. Find the right value. We got 47 microfarads in there. 47. Oh, perfect. We got a 1 microfarad right here. We got 2 1 microfarad capacitors right here. So this is the perfect example of what you do when you don't have a component that you need. So let's get some of these parts out of the way. And we'll desolder these 2 capacitors. So my soldering iron warms up extremely quickly. So by now it should be just about ready to use. We can trace back our 2 capacitors that we need to right here and right here. And we can desolder them. So, we're going to find the capacitors again, because I already lost track of where they went. Okay, so we're going to hold the soldering iron over them, and it already fell out, and I'll just grab that later. This one, also, this is also a good one. So we popped out our 2 capacitors. Let's throw the circuit board away real quick. just on the ground. Pick up our two capacitors. So now we have our two 1 microfarad capacitors for the inverter circuit. See, that is what you do when you're missing important components that you need for a circuit. That's why it's always good to have a giant stash of circuit boards. Okay, good question from Cool Boy Dude. So I am 16, and I do work at home. I still live with my parents because I'm still 16. But they think it's very cool that I do this kind of stuff. They like it a lot. So, good question. And if you have anything else you want me to do with my components, just go ahead and I'll build stuff. So right now I'm going to clean up these little solder leads on the capacitor because they're a little bit dirty. And they won't make good for sticking into a breadboard. Okay, good enough. So now that we have our components kind of cleared out, we can start building our circuit. So we have our two capacitors from the circuit diagram. Take a closer look at that. This is kind of hard to live stream this way. So we take a look at this. We have our two 1 microfarad capacitors. And we have our two... they keep flying away. Give me a second. So if we look right here, we have our two capacitors right here inside our inverter circuit. We have our two 16.5 thousand ohm resistors. They're just labeled wrong in my schematic. And my two 680 ohm resistors. We have our two MOSFETs, and we have our two little transistors. Now, I could build this all on a perf board to start out, but we want to see if the circuit works like it should. So we're going to start by building it on a breadboard, like this. Now, for anybody just joining, or that's on here, the reason this video is called Your Lab is My Lab is because I want you to tell me if there's anything that you want me to build, and I'll build it for you. Okay, so Android D just asked, there's a cool video about DIY instant heating soldering iron on Casey on TV. Can you make that project because your videos are easy to understand, please? Okay, so a DIY instant heating soldering iron. Now, I'm going to diverge from my inverter to help this guy out. And what we're going to do is we're going to get some coils. I'm going to show him how an instant heating soldering iron works and how I may do this project in the future. Thank you for asking. So right here I have a piece of nichrome wire. Now nichrome wire is commonly found in pieces of hair dryers. And pretty much what it is it's this wire that has an extremely high resistance. So that way if you apply a DC voltage to it, it will heat up. And this can be shown by turning on my bench power supply, hooking up my two probes to this piece of nichrome wire, and powering it up. Now, as you can see, when I turn up the voltage, the current goes up a lot too. Goes up to about 2 amps at 13 volts. That means it's drawing 26 watts. As you can see, it's heating up extremely quickly. It's actually glowing red hot. Now, this shows how it can melt solder, because if I take my little solder and I put it on, as you can see, it melts the solder instantly. And burns my breadboard too, apparently. So, this little tiny nichrome wire is able to heat up extremely quickly and melt solder. And we can even see how this can be used to solder by taking a look at these wires on my microwave oven transformer. If I can zoom in on this, we can see that if I hold this wire to this piece of copper wire right here, I'm actually able to solder. Oh, dripping solder on the desk. Well, anyway, that's kind of the basics of how an instant heating soldering iron would work. So thank you, Android D, for suggesting that. Just give me a second to zoom out. Okay, thank you, Android D, for suggesting to show how an instant heating soldering iron would work. Now, I may do this in a future video, so all I would have to do is take this piece of nichrome wire and wrap it around a metal head, and what that would do is it would let this heat up the piece of metal, and as you can see, that heated up almost instantly, and that would make it work quite well as a soldering iron. So I'll put that nichrome wire away and get back to the other project. Okay, so let's take a look right here. We got a piece of breadboard, and we have our components that we need. So first of all, usually MOSFETs go gate, drain, source, but since these are new, I'm going to check anyway. So I put these inside my little MOSFET tester that I 3D printed a case for. As you can see, it does go gate, drain, source. Where gate is where the control voltage is, drain is where you put the positive voltage on it, and source is always grounded. So I'll insert these two MOSFETs into my piece of perf board, and I'm going to start connecting them up in a way that would work. Okay, Cool Boy Dude asked me to make a Geiger counter. So I did make a Geiger counter already. Let me go get it for you. If you're still listening, just give me a second. Okay, Cool Boy Dude. So here's my Geiger counter that I made. Now I have a previous video showing this, and so if you really want to see how I made this, you can go check out that video, and I'll explain it quite well. So pretty much what this is it's a high voltage power supply, kind of like the inverter we are building right now. And it uses a 555 timer to drive this transistor that powers this transformer, which goes through a voltage doubler and 4 Zener diodes to regulate the voltage into this Geiger tube. Now what happens is the Geiger tube has this gas inside, and it has these two little electrodes inside. Now what happens is if a piece of radiation, forgot what it's called. But anyway, if radiation hits this, then it'll cause an electron to flow through because it ionizes the gas, and that will cause this Geiger tube to now what happens is thank you to the Decaptio family for following my stuff, my impressive home built projects. Thanks. Now what happens is this Geiger tube will cause current to flow momentarily through this piezo buzzer, causing an audible click that'll tell you when you have hit radiation. And so every time you hear this thing click, it's like a Geiger counter clicking to radiation. So thank you to Cool Boy Dude for asking about that. And throughout this video, if you have any questions about anything in my project, just ask and I will help you. So anyway, back to our inverter circuit. So we have two MOSFETs already that are gate drain source, and we have two transistors. Now I kind of forgot the layout of these transistors. I'm pretty sure it's emitter base collector, but let's just check to find out. I'll check this. Yep, emitter base collector. So we're going to use that in order to wire this circuit. So let's take a closer look. And I will also grab a bunch of excess wiring to use for my circuit. Okay, so what I'm going to do is I'm going to start by taking my transistors and putting some wires to the MOSFETs. So the sources of these MOSFETs are this bottom part, and those go to ground. So I'm going to take the source, which is gate drain source, I'm going to wire those two to the ground pin of the circuit. This will make sure that they are grounded and will work as such. Okay, there we go. So now what we need to do is we need to wire the drains. Now, to do this, we will take some more wires and connect them up to the two parts of this circuit. And I will also attach a positive center clip to the center tap of this inverter circuit. And I can take these two wires going from these two sources and use some alligator clips to connect them to the center taps of the transformer. And then this will complete part of the circuit, the actual driver part, and then we'll have to start making the other part. Okay, so Cool Boy Dude asked about the transistor tester, and I didn't actually make this. I bought it on eBay. And what this transistor tester does is it has a circuit board inside, and then it runs on this 9-volt battery. And what happens is if you put your transistor inside, it'll tell you the gain and the pinout of the transistor, along with some other important things. So that way you can see the readout on the screen. Now what this lets you do is it lets you see almost every aspect of a transistor. Now I didn't build the actual circuit part of it. I bought that on eBay for 20 bucks. But the 3D printed case I built, so that way it would be easier to use. Okay, thanks for asking. Now back to this part. I'm going to find some more cabling and connect up the source of this MOSFET to this wire right here. Because right now we are inside the planning stages of this inverter, and it doesn't need to be perfect yet. Okay, now that those two are just about wired up, we're going to have to take another wire going from the positive center tap right here. And we're going to have that go to the positive rail of the circuit. Now, for those of you who don't know how I'm getting my wires, I've got this little bin right here full of a bunch of wiring. And I'm just pulling wires out to use for my projects. Sometimes they're kind of hard to grab out. So I'll take one wire, hook it up to the positive rail, then hook it up to the positive of the transformer, which is the center tap. And so that completes our little power supply. I'm also going to add a wire to the negative rail and put that to the negative end of the power supply for use when we start running the circuit. Now, if we take a look right here, we're going to have to add the oscillator section. And this consists of 2 transistors, 4 resistors, and 2 capacitors. So we take a look at that circuit. We see that the base connects to the collector of 1 transistor, and the emitter goes to ground. So we can open this thing up a little bit. And we see that this goes emitter base collector, EBC. And so emitter will go right here because emitter is also the source of this transistor, so that's ground. And we'll do that for both MOSFETs. So there we go, emitter goes to ground. Now, the collector will need to go to the gate of each separate MOSFET. So we'll take the collector, and we'll put a little wire to it, and we'll connect that to the gate of the MOSFET. And I'll do that for the other one too. Collector to gate. I'll move it up a little bit. Collector to gate. I'll scoot that MOSFET back a little bit. Scoot the transistor. Okay, so now we have these transistors somewhat wired in. Now if we take a look at the circuit, we're going to have to wire a 680 ohm resistor from the gate of each transistor or MOSFET to the power line. And we're going to take a look at our 4 resistors, and we're going to pick out which one is which. So we know that these two are the same and these two are the same. And then, just to show you this transistor tester and how cool it works on different things, I'm going to insert that into the transistor tester and fire it up. And then you can see that that is 680 ohms, just like I thought. And By the way, the cool boy dude who said if I could live stream on Fridays. Maybe. I don't know yet. Depending on how well this live stream goes. So we're going to connect that 680 ohm resistor from the power line to the gate of each MOSFET. Okay. Now that that's done, we can start to insert the capacitors and the remaining two resistors. So if we take a look right here, we can see that the positive of the capacitor goes to the gate of each MOSFET. And so we'll try to meticulously insert these capacitors in place. Now this is kind of hard because these leads are pretty short, so I'm going to have to go grab some pliers to bend them in. Okay, so right now I'm just bending the leads out of these capacitors a little bit to insert them in. And we can see that the positive of the capacitor goes into the gate of the MOSFET. Sorry, I'm getting a little bit tired here. My speaking won't always be accurate. So I'm going to bend these leads on this capacitor, so that way it'll fit in. And likewise, I will connect that resistor in place and connect the positive of this capacitor to the gate of the MOSFET. And there we go, our two capacitors are in place. Now to finish connecting all the wiring up. So right here, we need to see that the other side of each capacitor is wired with a 16.5 thousand ohm resistor into the positive rail. So we'll go ahead and do that. I'll wire that to the positive rail here. Sorry, this is a little bit hard when there's a camera on a tripod in my way. Okay, that capacitor is partially wired to the positive rail, and I'll do the same with this one. Okay, now all we have left to do is connect those to the bases of the two transistors. As you can see, each corresponding transistor and MOSFET is connected to the other side via the base of the NPN transistor. Now this is so that way each side is controlling the other side so it can oscillate in the right way. So what we can do is we can take some more wire, which I have plenty of, and connect those two together. Got my hand stuck inside the mason jar here. Oh, and I just bumped my entire setup of wires. Okay, here we have another one. So I'll wire this side of the capacitor bank right here to the gate or the base of the other NPN transistor. I'll do the same with the other side. Hopefully, when we're done, we should have a circuit that oscillates normally. Here we go. Oh, that wire isn't going to work. Thanks to the people who are still viewing this. Bear with me here. This is going to be done soon. So we're going to connect that to the other base of the NPN transistor and connect this to the other side of the capacitor. And with that, our circuit is done. There we go. We've got a whole inverter circuit all put together on this little breadboard. Well, now is the time to see if this actually works. Scoot some of my parts out of the way. Set my multimeter right here. And we're going to see if this actually gets up to voltage. I'll turn this here, set it to alternating current. Now, before I actually connect my multimeter to this circuit, we're going to fire it up. Oh, well, it would help to connect the ground wire to the ground wire of the circuit. Nothing's going to work without that. Okay, hopefully this should be drawing current now. Oh. Oh. Uh-oh. something's not working correctly. Hey, Andrea. Okay, so something's not working exactly correctly with the circuit. As you can see, when I fire it up, it's causing my power supply to tank out on the current limiting part because it's maxing it out at 2 amps, which doesn't seem exactly correct, but hey, it still should work. So we're going to hook this up to my bigger power supply right here. And we're going to see how well this works. First of all, we're going to connect this inverter circuit to a little lamp to see if it actually lets it turn on. Okay, so I've got a little light right here. I'm going to connect that to the inverter so that way we can see how well it's actually working. Because this is a 110 volt lamp, and if this lights up, then we know our inverters work. Because sometimes these inverters can produce high voltage current spikes that can effectively fry almost any multimeter, because it's an upwards of 1,000 volts. So we're going to use this light as a load to see if this inverter actually works. This should work. Okay, let's see if this light will light up. Oh. As you can see, we have some light inside the light bulb, but we're maxing out the power supply. We may need more amps. Now, one thing that's odd about this is that it is drawing... Now, one thing that's odd about this is that it's drawing quite a lot of amps at only 5 volts. Now, this is a lot more power than it realistically should be drawing. So this is not good, and there could be something possibly wrong with this circuit. Possibly with these MOSFETs, possibly with something. But we're going to go against everything that I think we should probably do and connect this to the super power supply. Hopefully this will work. Just give me a second real quick. Sorry about that interruption there. So we're going to try and hook up this power supply to this very big 55 amp power supply, and all my instincts are telling me this is going to explode. But let's try it anyway. I'm going to move my camera right here. And here we go. Let's connect this up. I'm going to use some alligator clips. Hopefully this will work when I connect ground to ground, positive to positive. Well, this is something that might possibly explode. More like it will explode. Yes, fire equals cool. Most of the time, you may very well see fire right now when I turn on this circuit. So right now we have our microwave transformer hooked up to the inverter circuit. And that is hooked up to my 55 amp power supply because apparently my 2 amp power supply couldn't handle it. I'll wait till that little pour... Oh, never mind. Let's fire her up. Okay, you ready for fire? Let's turn this on. There you go. Seems like it's working. That's a 12 volt input into my inverter and a 110 volt output. Now let's actually measure the output on my multimeter. So I'll connect that to the two alligator clips that hook up to this light. Make sure to set my multimeter to alternating current. To that Lee Caprio family. Yep, it's alive. Okay, so now for the moment of truth. We'll turn this down. Yep, it's working. Not as efficient as I thought it would, but it's working. So we'll turn on the multimeter. Hello, this is standard check. We'll set the multimeter to alternating current, and hopefully this dummy load should take out any current spikes. We'll then fire it up. Yes, 115 volts. 115 volts is going through this lamp. That's enough to power, well, a lot of stuff. That's the actual mains current that's coming out of the wall normally. As you can see, the light bulb is lighting up normally. We've got a 12 volt input and 113 volt output on the output of the transformer. Now, keep in mind these transistors are getting quite hot during running, but that's fine because it's working as intended. So let's see what else we can run with this inverter circuit that we just built. And I'll make a real video on this inverter that's not just a live stream, that will be more thought out and more better edited together. Okay, so while looking at this multimeter to see if it's still working, let's connect some more stuff. So put in the comments what you want me to connect this inverter to see if it works. Anything. Okay, so this inverter right here can run lots of stuff. Right now I'm just having it run this little microwave light bulb. But if you have any other suggestions of what you want this inverter to run, put it in the comments because I'd like to see what you want and I'd like to help you with that. Now this inverter is kind of dangerous because we are running up 110 volts AC. But that's fine. With all fun comes danger. Connect this up here. Connect this up here. Okay, let's see what else we can run. You want me to run my... Well, the thing about the ham radio, it's actually a ham radio, not a CB radio. This actually runs off 12 volts. So if I turn on the 12 volt power supply, I can also turn on my ham radio right here and receive some stations. So, try saying something else, because that one already runs off 12 volts. Make a voice changer. Okay, a voice changer, I'll try. Maybe in a later video. I can't do that right now with the components I have. I'd have to do some research on how to make a voice changer, because you have to save the voice inside memory and pitch shift it while it is actually being changed. Okay, you know what? Let's find something else to run this inverter on. How about a lamp? Who's gonna get a lamp? Okay. Here we go. Here's a lamp. Let's run this thing. Set the lamp here. Connect it to the inverter. Now I'm not going to touch the terminals while it's running because that is potentially harmful. Okay, here we go. Here's nothing. Let's turn on the lamp. Oh, there you go. Look it, it's running a lamp. I'll turn off this other light to show you how well it's running the lamp. but it is actually lighting up my desk relatively well. This is putting out enough current to run this light bulb and this light bulb, and we're still getting 110 volts AC. It's actually pretty cool. Fire up the lights again. Okay, so as you can see, that inverter can run a lamp and another lamp, which makes it kind of cool. Okay, I smell smoke. Ooh. Okay, those MOSFETs are getting hot. They may need a heat sink for future use. Okay, let's connect it to the oscilloscope and see what the waveforms look like. Okay, yes, so Android D. The buzzing sound is coming from the transformer. It's kind of acting like a speaker. Now, let's visualize that buzzing sound. First, let's hear it. Now, if I feel the wiring in this transformer, or I feel the MOSFETs, I can kind of feel the buzzing sound coming from there. So, if we actually want to see what this waveform looks like, that's the buzzing sound, we can take a look right here at the oscilloscope that I'm firing up. Now, it takes a little bit to load. And there we go. So we'll take our probes, I'll set it to AC, and then I'll set it to 50 volts because it's a relatively high voltage. What I'll do is I'll connect my high voltage output of the inverter to this oscilloscope, and hopefully we should get a very good looking waveform of what this looks like when it's running. So I'll fire it up. And as you can see, the waveform is not perfect. So if we take a look at this, we zoom in, we can see that it is actually running, if I move my cursor right here, at 93 hertz. Now that's a little bit too much because this should be running at 60 hertz to run most switch mode applications and other electronic applications, but I can tweak the resistor values to get it to a perfect 60 hertz. Now another strange thing about this is that this is 50 volts and this is 100 volts. So this thing only peaks out at 100 volts and then it goes low. So if we put a bigger load on this, it wouldn't work as well. And as you can see, it's not a perfect sine wave, so this isn't a perfect inverter, but it's still good enough for what we're trying to build. It's still good enough to run a few lamps, a few other things. Okay, now let's find some other things to run with this inverter circuit. Some other cool things. Because this can supply a relatively high current to many things. So I'll plug it from my transformer. Put it up here. Turn off the oscilloscope. Okay. If any people want to tell me what they want this circuit to do, speak now or forever hold your peace. I'm gonna go find some more stuff for this circuit to run. Okay, you know what? I was thinking, and perhaps I could run my variable power supply right here. So I'll go down and I'll unplug that from down here. I'll try to find the plug that goes to my variable DC power supply. I'm thinking it's this one. Nope, not that one. It's always a game of roulette trying to find the right one. This one? Yeah, that's the one. Okay. So right here is the power plug for my bench power supply. So if I connect that to the inverter, we hopefully should be able to power this bench power supply with our own 12-volt power supply. And this should show how well this thing will work in other applications besides just having fun, because it'll show that this will also be able to be used for other stuff. Okay, anyway, let's fire this up. Now if I turn this on, there we go. This thing is running off the inverter circuit. Normally this power supply takes 110 volts AC, but it will also work on this inverter, as you can see. So if I take... This is interesting. What in tarnation? What the heck? Okay, sorry about this. So what's happening? Okay, never mind. Okay, I don't know what's happening here. Something shady's going on. I'm going to turn that off real quick. Okay, I forgot how I wired this up. So, apparently, what's going on here is, I forgot how weirdly I had this wired up. So this power supply is coming from the wall current. This is providing 12 volts. This 12 volts is being fed into the outputs of this power supply, which go straight to this. So this isn't actually connected to the power supply. Okay, never mind. I was just getting a little bit confused right there. So this is running fully off this part. So if I turn this on, this power supply is running completely off this power supply. Let's try another part from the desk. I'll disconnect that power supply. Sorry, I got a little bit confused there when the power supply turned off and I forgot that I connected certain wires together. Okay, let's hook up something else on the desk to this thing to give it a go. Perhaps. Let me think about that a little more. Okay, for those of you who are still watching, or watching in the future in my live streams, I'm going to find something else to connect this to test out its full load capabilities. You know what? Never mind. So, as you can see, that is how you build a relatively good inverter. And I will make a better video on this later. And I'm glad I was able to make this live stream. So, if you're watching this in the future and just want to comment on how this live stream goes, just put a comment on how you think it did. Put any improvements on here. Now, I know this live stream wasn't perfect. It was my first one, and usually I'm not too good at improv like what I did there. Sometimes I stutter when I do that. But anyway, that is a step-by-step thing of kind of how I think when I'm making a circuit. And that's kind of how I made this inverter. As you can see, it had a relatively good result with the light bulb working and it adequately supplying power to run this power supply. So, there you go. My first live stream, and I think it went pretty well. As always, thank you for watching, and stay tuned for next time. Okay, thanks Android V. It was a good live stream. Thank you for all the people who are saying this is a good live stream. So, if you want more live streams, then maybe I'll put some more live streams. But for now, I'm going to end this live stream because it's about time to go eat dinner. As always, thanks for watching and stay tuned for my next video. Tanner check out.